As with any dynamics question, we want to set it up in terms of a free body diagram first and then come up with our equation of motion. Now, because it's a combined mass question where there's more than one mass involved, I've drawn three different free body diagrams, one representing the entire system, in other words, all the masses combined. So I've got the 15 kilogram mass attached to the 10 kilogram mass via a little string in the middle, and the whole thing is attached to the ceiling of the elevator, and the elevator is accelerating in the upward direction. The 15 kilogram mass, if I isolate just it, you can see that I've got only three forces acting on it. I've got a rope attached to the ceiling, and then there's a rope attached to the bottom of the 15 kilogram mass, which we know is attached to the 10, but I'm only worried about the forces directly acting on the 15 kilogram mass. Similarly with the 10. So let's go through the free body diagram first. First of all, I've got two ropes, one holding the entire system to the ceiling. So anytime you have a rope, that's a tension force. Ropes can only pull. So I'm calling the top rope FT1, and it's holding the whole thing up. Now, none of these forces that I've drawn are to scale, but it would be obviously true that FT1 would be very, very large to hold up the entire system. So FT1 is pointed in the upward direction. And then if I continue on, this 15 kilogram mass obviously has a force of gravity acting down on it, and I'm calling this mass 1, so this is FG1. Similarly, there's a force of gravity acting on mass 2, which I'm calling FG2. Now there's also a rope in the middle, rope 2, and again, ropes create tension forces and they always pull away from the mass. So the top mass is being pulled downwards by rope 2, and I've labeled that FT2. And then according to Newton's third law, if it's the same rope, it's the same tension holding up the 10 kilogram mass, which is also FT2. So these two vectors are equal and opposite according to the third law. Now if I jump to my equation of motion, now I'll do this one in pink so we can see what's going on. It's always good to figure out which way the system's accelerating if possible. Now it says it's accelerating upwards at 3.2 meters per second. So my acceleration for all three of these pictures is upwards. Now that's not a force, that's the direction of my acceleration. So acceleration is in the direction of the net force. So if I take my free body diagram and then construct my equation of motion, which is always the same, my net force by definition is the sum of all the forces acting on the object. Anything that's in the direction of the net force is a positive contribution, and anything opposing it would be a negative contribution. So it doesn't matter what order we sum these up in, but it'll look something like this. F net equals, well, FT1 is positive, minus FG1, minus FG2. Those are both pulling down. Now I've got these green vectors in here. Now I've run out of space in the middle, but my two green vectors, and I might as well do them in green. One of them is positive, so if I continue with this sentence here, plus FT2, that would be this one, it's pointed upwards, the one attached to the 10 kilogram mass, and the other one is negative. So, as usual, when I look at the entire system, the force that connects the masses together, those two tension forces cancel each other off. So if we're trying to solve for FT2, looking at the entire system is not going to help us. So we're left with what's written in pink there. So now all it is a matter of substitution. F net's always MA. I'm trying to figure out what the tension in the top rope is. So we're looking for FT1. We know what FG is, mg. So FG1 would be mass 1 times g, and FG2 would be mass 2 times g. Now this mass over here, because I use the entire system, would be my total mass. So the total mass times the acceleration is FT1 minus m1g minus m2g. And it's just a matter of substitution from here on. So my total mass would be 15 plus 10, 25 kilograms. They gave me the acceleration of 3.2. So we know the left-hand side, we can get a number there. I don't know what FT1 is, but I know mass 1 is 15. Acceleration due to gravity is 9.8. minus 10 times 9.8. And if you take this and you isolate FT1 by adding whatever 15 times 9.8 is plus 10 times 9.8 to the other side, you end up getting an answer where FT1, when you round it off to the correct number of significant figures, is 330 newtons. Now let's move on to the second mass, because obviously we're trying to find the middle rope's tension. Now we can't do that with the entire system. The two green vectors canceled. But if I pick one mass or the other, the green force is on its own and it won't cancel off anymore. So let's look at our two equations. For the 15 kilogram mass, once again, it's accelerating up. We know that direction. So Ft1 is going to be positive and these other two vectors that are pointed down are going to be negative. So my equation of motion will look like this. F net for the 2 kilogram mass, or sorry, for mass 1, the 15 kilogram mass, my apologies, is Ft1, positive contribution, it's going in the direction of the acceleration, minus Ft2 minus Fg1. So F net 1 is M1A, because I'm only using that one mass, so the 15 kilogram mass times A. Ft1 we now know from our previous question. Ft2 is what we're looking for. And Fg1 is M1 times G. So if I take this equation and I isolate it for Ft2, I get the following. Ft2 equals Ft1 minus M1G minus M1A. Now Ft1 is 330 newtons. I recommend not using our rounded off answer. Use your answer that has a few more decimal places so we don't get any rounding errors. So we have this. We can calculate this. M1 is just 15 kilograms. We know G is 9.8. We know M1 again, 15 kilograms. We know the acceleration is 3.2 meters per second squared. So you should be able to get your value of Ft2. And again, when you use your significant figures, you should get 130 newtons as your rounded answer for Ft2. Now we should get the same answer when I use the 10 kilogram mass. So if I look at the 10 kilogram mass, once again, it's all connected, so it's accelerating upwards. Ft2 is positive and Fg2 is negative. So much simpler equation when you do the equation of motion for this one. F net is simply Ft2 minus Fg2. And this would be F net 2, just the 10 kilogram mass. So F net is Ma, mass 2 times A. We're looking for Ft2, and Fg is mass 2 times 9.8. So if I solve or isolate Ft2 in this case, I get M2A minus M2G. And we have everything. We know mass 2 is 10 kilograms. We know our acceleration is 3.2, etc. We know mass 2, we know gravity, we can get the same answer. I would always recommend that you do that if you have time. And again, when you use sig figs, you should get Ft2 to be 130 newtons.